So, next up, Ian Cotter, Cotton, Director of Energy at Manchester, just talking about some specific opportunities around energy.
Thank you. So I think I was asked because I'm one of the people who have pressed James and colleagues to kind of develop these ideas, but also because I already do some work with States colleagues on the estate, and they've been very, very helpful to me and colleagues, my students, both postgrad and undergrad. And hopefully I've been helpful back. I'd like to context this so in really what work the university does in the whole area of energy. And this is a discussion which I think we'll focus on a couple of tables a bit later. But we have over 200 academic staff who are PIs or CIs of energy-related research grants. And one can never quite be certain, but we think there must be at least 600 contract researchers, PhD students also engaged in these activities. A third of EPS research grants are in the area of energy, so about £80 million. So that's an absolutely huge resource. And as a concentration of energy researchers in the Northwest, even in the UK, it's massive. So then if the campus is having energy challenges, we should be putting those people to work. The other thing it's worth thinking about is, you know, these days with REF, impact, of course, is a key driver for the university community. So if we develop a widget, a technique, as part of the research, why should we be testing that out here and gaining the impact and showcasing that in the locality? There's also the social responsibility aspect, both the social responsibility of converting our research into new things, new devices, new thinking, and potentially showcasing it to people who walk around campus. So one thing I'm quite interested in as well is what can we do in the University Living Lab that we can make it not actually behind the closed doors of a cupboard, you know, in an electrical riser, but how can we also make it visible to people who are visiting and walking around. For the university, energy is a massive cost per year. We spend an awful lot of money on energy, and we do have this very challenging carbon reduction target that we have set to HEFCE we will meet. And we've got to somehow go forward with that. On a wider context, you may or you may not know, Greater Manchester is recognised by DEC, the Department of Energy and Climate Change, as a low carbon pioneer city. And there's lots of things now happening, not just within the university, but within the wider cityscape. And by city, I'm really talking about city region here, so all of the Greater Manchester authorities. And there's massive amounts of work that we're now doing with the local regional authorities to make sure, again, we can transfer our energy work into that space. I was trying to think about what some of the key energy challenges might be, and I'm an engineer, so I think in generally one dimension. But how do we reduce energy use in Grove University? What do we do about the design of buildings, widgets? How do we change people's behaviour? And I think Diane mentioned behavioural change. And I think that's a massive untapped area of activity here. You know, we have 40,000 students, 10,000 staff. An experiment that can see whether or not you can influence those people, for example, change energy use, would be absolutely fascinating. The university, in the context of the corridor, in the context of everything else around us, in the future must manage its energy usage in a coordinated manner. So many things being talked about now are we as an institution, how we use energy is also going to be dependent on how the people around us use energy. And there's going to have to be a lot of interconnectivity between buildings. So you've probably heard of things like smart grids or smart meters. A lot of that sort of stuff, everything will start becoming connected. So the university somehow is going to understand how those challenges hit it. I should have said mitigation here as well, mitigation and adaptation to climate change. How will that impact on the university and the estate? How do we cope with everybody in 7 years suddenly turning up in an electric vehicle, getting into the university car park, wanting to put an electric vehicle in? Oh, there's no sockets. I can't get home. So those are some of the example challenges that if we could bring our research to bear, it would be fascinating. Now, some example activities. I say I'm an engineer, so I like things that you can touch. I work on high voltage networks, so the university has 30 or so high voltage substations dotted around campus. I'm the sort of sad person who walks past them and actually looks at them. You will just walk past and not realise they're there in the majority of the cases. That network is essential to us. That supplies the electrical energy. But if you can monitor that, if you can control it better, there's many opportunities. So we work with Mike Bailey, primarily in Estates, who's one of the electrical engineers, to fit a couple of higher resolution, if you like, smart meters. The university already has energy monitoring, but that generally works one reading every 15 minutes. Our monitoring is about 4 times every second. Academically, for the researchers, that's really fascinating, high-resolution data that we can never, ever hope to get elsewhere unless we can persuade, the companies to fit things onto their system. But why should we when we've got the systems here? It's promoted teaching opportunities, and the students have developed that kit as part of third-year projects. Students are using the data now in research. But it's also, for estates, I think this is essential, given a two-way flow of information. We've said estates might be able to come to academics for help. I hope Mike Bailey has come to me and said, somebody is trying to sell me this low-loss transformer. They say it can save us this much carbon. What do you think? And I can give from my input. But equally, I can go to Mike and I can say, I can do with some data about installation of high voltage cables or something about systems that I can then use in teaching. And that information does flow both ways. So I think that's one critical point I wanted to make. We shouldn't see this in any way as a one-way relationship. It's definitely a bi-directional one. Another thing that's taken place, just as an example, is there's a lab in Sackville Street building. So Sackville Street building, very, very old Victorian type building. And the students and the staff have been engaged in work where they've designed automatic heating controls, window openers. There are switches in a room, so you press a button which basically says, are you comfortable? Are you warm enough or are you too cold? And then it gathers that information and it sends it back to the controller, and based on that, it varies. It varies how the room is heated. Now that's a really good thing in terms of human behaviour. If only there was a button in this room saying too hot and but things can be done at totally different scales. So that's something very, very much on a single room. The thing at the top on the distribution network is something much, much bigger and much more at scale. That, just to give you an illustration physically, and I like these sort of pictures, is the sort of thing that we do, so that they're the main power cables which are going to be Bridgeford. So for those of you in humanities, I think James sits in Bridgeford, hopefully quite of them will never ever cut you up. But that's also a good example where we had to work with Mike and colleagues to make sure what we were doing would not interfere with the safe, usual operation of the estate and the facilities. The other thing I was quickly going to say is we should also think about opportunities further afield. So Diana mentioned the estate that we have here. I mentioned briefly the opportunities in Greater Manchester, but one such one is NADO, who are the Japanese equivalent of UKTI. They are funding a large-scale rollout of heat pumps in Greater Manchester. So these will be heat pumps, so instead of using your normal gas central heating, you take electricity, you basically have a fridge in reverse or an air conditioner in reverse, and you suck heat out of the air and put it into the house. You basically get about 3 kilowatts of heating for every kilowatt of electricity that you put in. That is the theory. That, as a trial at scale, that university researchers could engage with. It's in social housing. So how do those heat pumps benefit those people in social housing? Does the engineering of them make sense? There's all sorts of avenues with which we could engage. The other thing is we also have now a university site in Cumbria. So this is Dalton Cumbrian facility. So this is home to some nuclear work, really, some nuclear R&D work. But it's a facility which is in essentially a rural landscape. So our limitations on this part of the campus focus are certainly much more urban environment focused. There's various discussions with England Cumbria, not just about how to do things at DCF, but also in the wider Cumbrian environment. They're looking to develop, for example, tidal energy facilities. How can the university support those? Bioenergy. Do we need fields to grow crops or to grow bioalcohol? There's all sorts of potential opportunities. So that was just a flavour, I think, of the sort of things that might be possible in energy, and hopefully there's loads more. But that's the sort of relationship that so far has worked. Just in terms of energy, if you do things in energy, I'd love to know about them. So that email address is probably the best, because that will get to me. And also, just as somebody else useful to know energy, Teresa Chilton, who's on a middle table there, she's going to start work on the 1st of September as project manager for Manchester Energy. So that email address will also find plans to help. Okay.
Thank you very much, Ian. Final speaker.